morning, good afternoon, everybody. Thank you for joining us for our weekly HSM Hangout. My name is Jordan Roberts. I will be your host today. Very excited. We've got Wayne Griffenberg, Autodesk Application Engineer, and Wayne is going to be covering adaptive clearing. As you guys know, this is a technology that you can leverage in our free products, in our premium products, on the cloud products inside of Fusion. It's going to really help you reduce your cycle times. Wayne, thank you so much for joining us today. I'm very excited to see what we have going on. I want to ask a couple of poll questions really quickly. As always, we like to understand where everybody's at, what they're using, what their experience is. So here, let me get the poll fired up real quick. And we'll rush right through these. So as fast as you guys vote and answers, as fast as we'll get through it, I want to understand what kind of CNC machines you guys run. Wayne, any thoughts here?
I have a feeling we're going to see a lot of Haas.
Well, maybe the reason for that is that, you know, they're the most popular out there, and they're also turnkey for HSM, so that's great news for our customers that need post-processors for Haas. Okay, let's close these polls. Share the result. Wow, look at that. 63% Haas. That's awesome. And guys, this is a live Q&A, so feel free to chime in for those that are in the other category. Let us know who you are, what you're using. You know, and throughout the presentation, if there's anything that doesn't make sense, we also happen to have product manager Al Watmo standing by as well. So we've got a lot of resources invested in these HSM Hangouts. I also want to understand how long everyone's been exposed to this technology. Are you brand new, a couple of months? What we've been finding is a lot of people are joining us week over week in these HSM Hangouts, and so we want to make sure that we're continuing to add value and make these things better. Now, Wayne, any thoughts as to what the distribution might be for this one?
That's a tough call there, Jordan. Let's see.
Well, so we're looking at a really good distribution, and thanks for the answers, everyone. 29% brand new, 35% a couple of months, and what's staggering, the majority are repeat and have been using HSM for longer than 6 months. So we're building the community. Thanks, guys, for doing that,
Awesome.
being involved. We just absolutely love it. Now, this is a great one. You know, what CAM software do you guys use today? I have a feeling that the majority is going to be HSM. That's just what I'm thinking. All right, polls are almost closed. Wow, look at that. Wayne, 61% using Inventor HSM or HSMWorks. That's the SolidWorks package. InventorCam, that's a great package. I'd encourage all of you using InventorCam to really look at Inventor HSM. You get a free seat of Inventor CAD when you sign up. That's great.
That's awesome.
All right. So one last question. I want to understand the industries that everybody's serving. It's okay if, you know, you maybe serve a couple of these. Just submit your best answer. Great. And for those in the other, feel free to shout out who you are, what you do. Also, feel free to include links to your Instagram handles. I don't know if anyone's following us on Instagram, but we always encourage interact with the application engineers via social media. And if there's anything that we can do to promote your business, if HSM has been a success for you, let us know. So Wayne, without any further ado, enough blabbering from myself. Tell us a little bit about what we got going on with the adaptive clearing. This is an incredible technology.
Awesome. Thanks, Jordan. So that's what we're going to talk about today is adaptive clearing. It's our roughing strategy, high efficiency toolpaths that we have, strategies that we have in our HSM products for removing those chips really efficiently. One of the main things that we want to do is we want to reduce those cycle times that you have and increase your cutting tool life. One thing I want to bring up was Al Watmo from our product development team, or he's actually our product manager, worked with Dan at Pier 9. Pier 9 is a great place. If you haven't been out there, it's in San Francisco, right on the bay. An awesome place to visit. If you can get out and take a look, they're doing some great stuff at Pier 9. We have the Haas machine. Al worked on the Haas VF2, and he did some testing. He and Dan did some testing and looking at the benefits that you'd find the high efficiency roughing, which is adaptive clearing, versus traditional roughing. Some of those things that they looked at was a holder that can look at the load spikes. It sensed the load spikes when you're running toolpaths, used it to test the loads and temperatures that they would find when they're running traditional type toolpaths and they're running our high efficiency adaptive clearing toolpaths. And it took a look, and what they found was the traditional roughing toolpaths use an offset from the geometry you selected. And those offset passes, that's what your step over is going to be. That against our optimal load inside of adaptive clearing, you're keeping the constant radial tool load in adaptive clearing. So when you take a look at it, the traditional roughing or increase that radial engagement in the corners, especially when you go into those tight corners or acute corners, you'll find that tool gets literally overloaded. It gets buried in the corner, and that's where you'll have a breakage of your tool. Maintaining that radial tool load throughout the entire cut, you can get into those corners, keeping that same load on the tool. You're going to reduce or eliminate any of those load spikes you find on the tool that cause it to break. Really good information as they took a look. This is the feedback. They were constant load, always the same load when the tool is in the material. So they're able to find by that, they're able to run at higher spindle speeds. You can keep that tool down in the material as much as possible, use as much of that flute length as possible, because you're able to run at a constant chip load. In other words, you're keeping the axial engagement and you're keeping the radial engagement at a constant small cut, a small bite as it goes along. Really efficient keeping those load spikes down. So, and another thing they show in the video is walking through ways that you can find your feeds and speed and setting up the right feed rate, running your spindle a lot faster. And we find that if you run your spindle a lot faster, you're able to cut the material. You're not getting as much heat in the tool. So if you optimize the right tool with the right material and get the right feed rate, you're really going to optimize and get those parts off the machine a lot quicker, and you're going to save your tool life. They also looked into, or we use the step-up pass in the 3D to keep a constant amount of stock in the model. You're keeping that constant amount. And also looking at when there's a transition from one place in the model to the other, keeping it safe and trying to keep the tool down. So these are really great places where we can help reduce those cycle times and increase your tool life. I want to really hit some points. Now, there's a lot in there that we can cover. It's going to be tough to do in one webinar, but I'm going to try to hit some of those points where we find a lot of questions and things that I think will be beneficial for you. Talking about being able to use adaptive clearing for facing, using the tool shaft and holder to check to make sure that adjustments are made in the toolpath to be sure that we're not going to gouge the material or gouge our part. And also our stay down level. We really want to spend some time on here and kind of explain, well, not kind of, we're going to explain more into what that stay down level means. Okay, so let me bring up my SolidWorks and we'll get into the toolpaths. Just to show you, I'd like to give an idea. I have some of these toolpaths on this part right here. So I'm going to zoom in a little bit. And so just like the traditional toolpaths, you'll see they're offset toolpaths. In other words, it takes a step over that's offset from the geometry you selected. Traditionally, we'll take a look at the first time they work with these offset toolpaths, trying to get it work, but you notice when it gets into those little corners there, as we saw in the diagram, that's where a lot of the load is on the tool in those corners. So what they'll do is they'll run really slow. They'll have the tool go in really slow into those corners, into the feed rate. They'll slow their feed rate down at the machine and work their way through the pocket. And you'll also have shallow step downs to try to keep the tool from breaking. So what we do in our adaptive clearing is we helix down into the material using as much of that flute load as flute length as possible. As it helixes down, I have a taper helix here, which helps that swarf get out as you're working your way down into the material. It gives it room for those chips to fly out, as well as it prevents recutting of the chips and work hardening. So as it reaches down to the bottom, it keeps that same constant chip load, that same radial engagement the entire time as it works its way into the material. So you can run at your higher feeds and your higher speeds because you're keeping that same size chip the entire time. As it works into those corners, again, that same size bite, and where it can't keep the same size chip, it backs out, comes back in for another bite. And that's how the adaptive clearing works, really high efficiency clearing. So as it works its way into that pocket, you're not going to see any burial. And when it reaches the point in the corner of the pocket where traditionally you would have a broken tool there, this is actually going to take that small little bite. So it's not going to bury the tool. You'll get your parts off the machine a lot quicker. You can run higher speeds and you can trust that it's not going to give you those load spikes in the corner. Really good toolpath, really good algorithms, high efficiency machining. So let's take a look. I'm going to walk through setting one up. So let me delete these out real quick. I'm just going to go to delete, just right click, delete. I'm going to start, this is my job setup. So I'm going to add a 3D adaptive clearing toolpath. So if you're new to working with HSM and you're new to adaptive clearing and any of our toolpaths, one thing you'll find as you work with our toolpaths, really simple, really easy to use. It's always the same workflow as you go through and setting up your toolpath. So all of our toolpaths have the same workflow, really easy to learn. So working from left to right, I would select a tool. So if I go to library, I can select a tool out of a library. I suggest making a library that matches the tools that you have in your machine and set up like you can do it by machine or you can do it by material. For aluminum tools, I have my feeds and speeds set up for my aluminum tools. We have a library here that was set up for Pier 9 using the same library that they use there for the tools that we work with. So you can also import and export your tool libraries. I'm going to select a tool out of this library. These are tools that I was working with previously. I'm going to select it, brings it into my graphics view so I can see it. I'm actually, you know what, I want to face this off first before I get into those pockets. So I have that stock there that I want to remove from the top of my stock down into the part. So I'm going to select from my library, I'm going to choose a face mill into my adaptive clearing toolpath. Now with a face mill, I can use adaptive clearing to do a facing toolpath. All I'm going to do is go over, and we'll talk about more of these things as far as the geometry and the heights are concerned. Actually, let's get into the heights. What I want to do is I'm going to change that. Instead of being model bottom, I'm just going to change it to model top. So I'm looking at my top from the top of the stock down to the model top. In my passes, again, we're going to talk more about these things, but you see this exclamation point, yellow exclamation point, give me a warning, saying my step down is a lot more, or in this case, yeah, my step down is a lot more than the flute. And I have a face mill, so I don't want to go too much past 1/10 of an inch, or else I'm going to be at the top or the bottom of the screw holes, and I'm going to pull my inserts out. So let's say we do 50 thousandths step down. Okay, we're going to talk more about these other settings, but I'm going to leave it at that. I'm going to say OK. Okay, and we get this adaptive clearing facing on the top of the part. So I'm going to simulate it so you can see it. Going to play, and it's going to face off the top of the part using that adaptive clearing. Really, really efficient way to face off the part. So we have a traditional facing, but this is a good way to do it. It's a neat trick to be able to face off the top. Okay, and I like the way that that worked. I want to save that. I want to use it. There's my report. So what I want to do is I'm going to create a template. So I'm going to right-click on that toolpath. I'm going to go down to create a template or store as template. So storing as a template, I can save any toolpath and I can reuse it later. I did it earlier, but I can overwrite the one I have here. But you can save a template. It's a good idea to create a library or a location, maybe even on your network that you can share them. But it's a good idea to create a place where you can save your toolpaths. So as you create them, you don't have to recreate the wheel. You just reuse what you've done before. In this case, we can save it as an adaptive face. I'm going to say yes. And now if I want to be able to do that, I'm just going to delete it for a moment just so I can show you. If I bring in a part and I want to be able to get that adaptive on it, I just right-click. I'm going to say create from template. I'm going to go, I can choose where that template would be. In this case, I have it set in that adaptive clearing folder. I can bring it right in. And all I have to do is regenerate the toolpath, recalculates, looks at the part, and applies exactly that same adaptive face.
Wayne, I'm going to jump in because there's a great question here. A user wanted to be able to apply a finish pass in adaptive, and templates is a great way to do that. So you could have done a derived operation. I just want to point out that a template can be a series of operations too. It doesn't just have to be one operation. So you could create a template of your roughing operation plus your finishing operation together.
Absolutely. That's a good point. Thanks, Al. So you can do that. You can create your derived operations. You can have your roughing and clearing operations set up, and then save all those as a template and bring them into your part. So I'm going to walk into another 3D adaptive. I want to be able to cut the part. I want to cut inside the part, so I'm going to go and select another tool out of my library. I'll use this 3/8 bull nose. Select it. I can see the tool, brings it in. Now, if you're new working with the toolpath, working from left to right, we select the tool out of our library. The next step would be selecting any geometry. Now, for the 3D toolpath, it's really about setting boundaries where we want to keep the tool in that area. So when you select different boundaries, we have our bounding box, which is relative to the X and Y of your WCS. It'll give you a box around the part at the extents of the part, as you can see the picture, and that'll be where the tool will be kept. And we also have the silhouette, which is a projection of the silhouette, the shape of the outside of the part, and that's what it's going to use. We can also select specific geometry. Now, if we select none, it'll use the stock, as you see here, as a contour on the stock automatically. So here I'm going to do a selection, and I can keep the tool. I just select geometry right off the model. It projects it into the plane where I'm going to be working with it. And now I'm going to use that as a boundary to keep the tool inside that area. So I can keep the tool inside. Other settings we can do, rest machining. Rest is remaining stock, is what rest is meaning. And we can do that remaining stock if we have previous operations. In other words, we have a previous operation which is our facing, but our facing didn't do anything inside that pocket. But we can do previous operations. We can select specific operations. We can also work with a file if we have another file. Pick solids. You might have a solid model that represents your previous operation, or even from your job stock. So we're going to leave it at job stock so it recognizes the stock that we're trying to remove into the part. Okay, so I'm going to get into these things a little bit more, but I'm going to go and say, okay, actually before I do, I want to make sure that it doesn't cut anything above the part. I know we already machined off the top of the part, but I want to make sure that the tool stays down inside of that pocket. So what I can do is, instead of choosing my bottom from model bottom or my top from stock top, I can say from model top. So it's real easy to work with the heights. You can select heights off the model. You can select specific positions off the model. You can also choose the model itself to regulate where the height of the tool is in the bottom of the tool, where your clearance and your retract will be. Really quick and easy to easy to use. We're going to get into our adaptive clearing a little bit as far as our passes are concerned, but I want to show you right here is where you can set. This is your optimal load. We talked earlier about setting that optimal load, keeping that consistent radial engagement the entire time. If we right-click in this field, we can go down to Edit an Expression, where you can hit F2, and this brings up the expression window, and this is what's driving that optimal load. It's the tool diameter of the tool we brought in multiplied by the factor here of 1/4 of the tool diameter. We can change this if we want to get a little bit more aggressive. We can make it 35. Again, work that out. When you get your tool and you find the right tool for the job and you have your manufacturer's recommended feed rates to start with, and also take a look at that video that Al put together with some tips on being able to build up your feeds and speeds to match what you're trying to do. But here is where you can fine-tune that, and you can put that information in to keep your constant radial engagement. This is what's driving it. So I'm going to say OK, calculates, and it gives me that new optimal load. So I want to point that out. You can do that on all of these different fields. This is the minimum, and this is the minimum radius that the tool will look at when it gets into the corners. If I hover over, it should give me some pop-up. Minimum cutting radius, and we'll take a look. at the difference here. But again, I just want to show you, this is when it gets into those corners, you can avoid having that tool go into a corner where it may not be most efficient to be able to remove the chips. So we'll walk through some of these when we get into the other aspects of the 3D. I just want to point those things out. So I'm going to leave it there. I'm going to say OK. It's going to calculate, and then I'll have that adaptive clearing on the inside of that feature. Okay, so I was able to bound it. Now if I go and I'm going to right click, I'm going to edit that, and I'm going to change it so I can cut the outside of the part. So all I'm going to do is remove my boundary and say none, hit the green check, and it'll calculate, and it's going to look at everywhere on the model where it can efficiently remove those chips. It's going to try to keep it engaged, that tool engaged with the model as much as possible without interfering with the model, without hitting the model. So it really respects the model very well. And if you notice, you see a lot of these retract moves are here. Actually, I'm going to show you, there's another place where we can see a lot of them too. So if I'm going to go to edit, I'm going to go into here and I'm going to show you. Down here we have our linking parameters. Linking is where we can change those retract moves that we see here. Just I want to point out too, as before we go to change those, I want to show you that it's going to work its way. The tool is going to work its way. The algorithm is going to take a look at the most efficient passes. It's going to work its way up the side of the model here, and it's going to try to look at where it can leave the most efficient stock, or at least a consistent stock as it goes through to remove the chips. So we can take a look at that. I'm going to do a stock simulation real quick just to show you as we walk through. So it's using as much of that radial engagement as possible, as much of that flute. You see it's getting pretty close to my holder there. Okay, we're going to take a look at another setting for that in just a few. But you see it started where it can get the most efficient cut going around the part as it steps its way up. Looks like I hit down here. I don't think I selected to do the face, and that's why it looks like it hit. So I only selected the one tool path, but if I select the face, you'll see that won't be there. But there it's working on the inside. Then it comes out and looks at the next level where it can get the most efficient cut. Okay, so there it worked up the walls, and it worked the inside, again, keeping it most efficient engagement as it can. Okay, so you might see some retract moves in here, and sometimes you might not want to see all those retracts. You want to be able to see them more minimized. What you can do is you can edit and go into the linking parameters. So this is some of the questions that we get often is understanding this, the retraction, the stay down level, and how we can adjust it to keep that tool engaged as much as possible in the most efficient way. So when we look at our retraction policy, this is really looking at whether we're going to retract all the way up to the full retract level, or if we're going to have a minimum retraction. In other words, when it moves from one place, it's going to retract out to move over to another place where it can safely re-engage the material where it's making that most efficient cut, because it's going to avoid hitting any of those bosses or any of those areas. We can have a minimum retraction where it's going to try to move out. Instead of going all the way up to the retract level, it's going to find a really safe way to move around, but keeping the tool down as much as possible. Here, what we're looking at is our maximum stay down distance. So this is really the distance, because the adaptive clearance, it's going to keep looking at, or in other words, it's going to keep reevaluating the material, the stock, and the part to keep getting that most efficient tool path, to keep the tool engaged as much as possible. So it's going to keep reanalyzing the moves that it's doing and looking at the different places on the model where it's most efficiently going to take that bite. This distance is our minimum stay down, or I'm sorry, our maximum stay down distance. This is the distance where the tool is going to look and say, within that distance, I'm going to, if I don't see another way around this boss, I'm going to raise up within that distance to another area on the part where it can efficiently start removing those chips. You can increase this distance. If you do increase it, I'm going to show you here. Right click, edit expression. This is also an expression. It's a factor multiplied by the tool diameter. So this is the way it would come in as default. And if I wanted to make, let's say, 20 times the tool diameter, what I've done here is I've increased the area that it's going to look So when it goes to retract from one spot in the material, or when it's cutting here and it can't efficiently keep cutting, it's got to move to another area, it's going to increase that area where it's going to look for another place to move in. So again, it's looking for that most efficient cut, the way it can remove the chips in the most efficient way, keeping the tool engaged as much as possible without hitting the model. So our stay down level, within that distance, we can tell it a certain percentage of that distance to stay down. So here it's looking at, if we did least is 0%, in other words, it's going to keep retracting as much as possible without hitting the model. What we can do is we can increase this. Let's say 30%, we can do 50%, and we're doing 3 1/4. So if we're doing 50% of that distance, it's going to look within that 50%, that 3 1/4, it's going to say, can I stay down here? If it can't, it will retract and move over to the other area. So that's really what it's doing. But one of the trade-offs is you get less retract moves. One of the main things that we do this for, sometimes you have a machine where your rapid speeds aren't that quick. You might have, your machine might not be able to get your rapid up as close to your high feed. And so those retract moves take time. They take, they're not as efficient. You don't get the part done as fast as you can. So if you can have your tool stay down, move to the next area that's closest and more efficient, it'll do that. You can enable that with your stay down level, but that's really what it's doing. It's trying to keep that tool down so you're not doing those retract moves and taking that time. So it's trying to keep it down as much as possible. You can also have it here, you can say I have a specific feed that I'm trying to do as it goes through, as it goes from one area on the part and tries to stay down. Okay, so one of the trade-offs here is you can go higher. You want to try to have that tool stay down as much as possible, but what you're going to get is the trade-off is more code. It's going to calculate longer, It's going to take a lot longer to calculate. So it's going to try to, the algorithm is going to try to take a look at what the next most efficient move will be within that 60% of that distance, and it's going to keep calculating that 60% as it works its way around the model. So your calculation time is going to increase. Go ahead, Al.
Yeah, I just maybe jump in because this is definitely something that a lot of people have confusion with.
Oh, please, yeah.
It's good to explain it from a couple different perspectives, and you've done a great job. So the stay down linking, for people who have been using it a while, there's a maximum stay down distance up top that Wayne was talking about. That's 7.5 inches. That's if it can just find a straight line between 2 points. But that's also an overall maximum distance. And then we have this new linking that's going to find the safe path, this stay down level percentage. It'll find a safe path, and it'll jog through and it'll go searching. It's aware of the stock, whatever your stock model is at that time. So as much as you've roughed, that's the model it's using. And it's trying to find a way to get to where it needs to start the next cut. Well, the way the calculation works is it first calculates the rapid movement that Wayne was showing you. It comes up, it comes over, it goes back down, that sewing machine, because that's a very fast calculation to find out how long that distance is. And then we know how long that is. So let's say it's let's say that distance is 1 inch up, 4 inches over, and 1 inch down. So you've got 6 inches of motion. And now we set the stay down level to 50%. So that's saying if I can find a stay down distance that's half as far as my rapid distance, I want to do that. Why would you do half as far? Well, usually your rapid is 2 times faster than your cutting move. So it says 50%. So it starts looking, and it's trying to find something. It's hunting its way, and it gets to 3. It says, I'm going to stop looking. I'll just use the rapid. The reason that's important is that'll add a lot of calculation time because it is intensive to find that safe place through the in-process stock. So you only want to use the percentage that's high enough to balance calculation time with keeping that tool down in the cut. Now, as Wayne said, sometimes you just want to force it down, so set it to most, and it will force it to stay down even if it's 10 times longer than doing the rapid move. I also like doing this just if you are using a rapid move and your boss comes by and says, well, why are you cutting air so much? You could run the part a lot faster. this is a great chance to show them, I can actually calculate and show you that it's less motion for the tool to come up, move over, and drop back down. But hopefully that just in a slightly different way helps explain what that's doing, because I know there's a lot of confusion around how that particular switch works.
Thank you, Al. Awesome. And you guys are hearing it from the man himself, so it's awesome. Thanks for helping out. So as you can see, it's going to take a little bit longer to calculate. But as Al had mentioned, it's going to take that long because it's looking for the best distance, or the best shortest distance it can, or at least where it can stay down. And you can see you're getting all those stay down moves right here. You don't see all those large linking moves going from the, or that's going from the inside, but going from one side of the part to the other. So you can really reduce your rapid moves. You can keep the tool engaged in the material much more efficiently, but that's the trade-off, is if you have larger parts, a lot of tool paths that you're working with, it'll take a lot longer to calculate. Very cool. Thanks, Al. So I'm going to go and I want to show you something else that we're working with here while I have this tool path. Now let's say I only wanted to cut the outside, and I don't want to cut the inside of this part. Let's say I want to do that with a different tool path. If I go in and edit, what we can do is in our passes, I can tell it that, oh no, I'm sorry, not my passes, in my geometry. I'm actually forgetting where I am here, Al. I can, oh no, that's it. I want to machine. Sorry, guys. My brain is going somewhere else here. So one way I can do that, it's right here, machine cavities.
A couple questions here that I'm going to answer.
Sure.
So I'll let you jump back in. There's one question regarding how do you avoid clamps. It is in our backlog to add automatic fixture avoidance. But a nice little trick is there's a model override in all of the tool paths. You can define your clamps, and generally I like to draw them oversized when I do this, define them as model, and then the tool pathing algorithm knows, well, I can't touch that. That's part of my model. If there's no stock around them, it's not going to go over in machine, but that'll make sure that the tool path algorithm does not touch them. So that's a bit of a hack, but it will help you force the tool path to not hit your clamps. As far as the time savings on keeping the tool down, if you're running prototypes, I would be having all my defaults set to do the safest thing possible. To me, the most important thing in your situation is you want to be able to hit go with confidence. You're not looking at saving split seconds. So I don't think I'd even use the stay down linking, to be honest. Sorry, Wayne, hopefully you're back to where you wanted to be.
Don't be sorry. Thanks, Al. So I had a brain fart there, but I'm back. So what I want to do is I want to remove machine cavities. And what it'll do, it'll recalculate, and it'll look at any place where it's going inside the model. It's going to recalculate, and it's only going to cut on the outside of the model. We kept this at most, so it's going to take a little while to calculate. When it gets there, you'll see it's only going to cut from the outside of the part. It won't try to cut inside the cavity. So that's one way you can keep it from going inside your part where you don't have to cap it off. So I'm going to go back. I'm just going to change that real quick back to lease so we can get a little bit more of a faster calculation. But I want to show you one more thing in here. There's places where we can say machine shallow areas. When it's cutting those areas, it gives you those extra passes around to make sure it gets into those shallow areas. Flat area detection. So if I have in my part, in this case, I wanted to calculate, and I have in my part a version of this that actually has like some flanges on it. And so what it'll do, it'll calculate in my adaptive. Let me go and regenerate this. It'll calculate, it'll find all those places that are flat in the toolpath and go in and be able to clear them. So it's finding those flat areas in the toolpath as it calculates. Another thing that's important I want to show you too, that's going to be really helpful, I'm going to go and change my model back real quick. Let me go and change this. I'm going to go back to my original. Actually, as a matter of fact, if we had our toolpath, if we look at our height like this, Okay, I'm going to go back and I want to show you. This is a larger part. We actually have a lot more height on the part. I'm running the same toolpath, so I'm going to go and regenerate. It recalculates the new geometry. Okay, it gave me the adaptive face on that new geometry. It raised the part up. It recalculated. Now I have a higher part. But if I take a look at this, I'm going to go and simulate real quick. I'm going to go to stock simulation. I'm going to let it play through. And you'll see, as it goes through, there's places right here where you can see my tool holders hitting on the edge right there. Okay, I want to slow that down, but my tool holder, and I'm getting feedback right here that we're hitting right on the holder there. So one tool that was added by the team, which is awesome, in a recent version, I'm going to go to edit this. If I go into under here, shaft and holder, you can tell it to detect the tool length, which we'll look at, or pull away. You can have it fail on collision and stop, and you can go back and at least it gives you some information feedback saying you're going to hit. You might want to change your tool or come up with another way or find another path. We can tell it to pull away. So if we take a look at that, what you'll see is that we go through, and we're going to do a stock simulation again as soon as it calculates. You'll see it's going to calculate those places where it's going to hit that tool holder, but it's going to pull away from the material. Okay, let's go and take a look at that stock simulation. Slow it down a little bit. Go ahead and play. There's doing our face, our cool adaptive face. Okay, and as it works its way down, or it works its way into the material, those places where it was hitting the part, I don't know if it's giving me a good simulation here, maybe I'm speeding it up, but that's just graphics. But it gave me this area right here where it pulled away from hitting. So it recognized the place where it's going to hit, and you can give it that distance that you want it to stay away. The other way, another way, and I think it's really cool, if we go and edit this, I'm going to go and change that, and I'm going to say detect tool length. So what it's going to do, if it calculates, it's going to go through, it's going to calculate the best, most efficient way to keep the tool engaged, and it's going to recognize the places where that tool is going to hit my part. See how it went red here? I have this red X. I want to take a look. I'm going to right click. I'm going to go down to my, I want to show the log, and it tells me right here, the tool length has been updated from 1.125 inches, an inch and an eighth, to 1.57597 to ensure that the holder doesn't collide with the part. So this is a good way to help you select the correct tool length that you would need to cut that part. So it updated my tool. Now if I regenerate this toolpath, it's going to calculate with that new tool length. So I can go back and say, do I have a tool that's an inch and a half or maybe an inch and 5/8 that I can put in there to make sure that it's not going to collide?
So two things there. One, that's a bug. You shouldn't have had to recalculate. It wouldn't be the case for any of the other 3D operations. So I'll get that logged. I'm glad I was on the webinar. The other that I think is important for everybody to know is that I talked about adaptive in the stay-down linking being aware of the in-process stock. That's also the case for the shaft and holder avoidance. Is when it's doing it, it's looking at what material has been removed already by that operation, which is technically unique compared to some of our competitors. Anyway, thank you, Wayne.
Yeah, I think it's great. And now if we take a look, go into my tool, you can see it's been updated. My tool has been changed to the new cutter that it needs to be. But you can also go back and say, okay, I need at least this much, or this body length, and I need at least this much shoulder. They're going to be able to cut this different part. So it's good feedback, good to be able to work with it. Really nice functionality inside of Adaptive. So those are some of the main things I wanted to cover today. I know we're getting pretty close to time. We have some time for questions. But that was our deep dive for today. We're going to have a lot more coming up in the near future. But those are some of the points I wanted to make sure that we covered. And I really appreciate it, Al, that you're here and able to jump in and being able to help everybody understand more about what those really awesome functions are inside of Adaptive.
So Wayne, you're not done yet. You've done a great job, but there's some questions that I'm glad you hit on.
Awesome.
First and foremost, the last question here is it available in 2D or is it only in 3D? Well, I guess there's two answers to that question. It's not available in 2D, I'm sorry. If you're using Express, then you don't have the functionality. If you're using the full paid product, I think oftentimes users miss that the 3D strategies are very useful for what I would call a prismatic part, a part where you would generally think you had to use a 2D strategy. So the way to think about 3D toolpaths versus 2D toolpaths is kind of how Wayne's been describing this part, but I've got a friend, he's known as the Bear Man. He carves bears out of trees with a chainsaw, and I asked him once, how do you even know where to start? Well, I, for one, am a machinist, not an artist, but that's part of the problem. The second thing is, well, I just cut away everything that's not a bear. And I've used that analogy a lot because it really describes how the 3D toolpaths work. They just start at the stock and machine to the model. Yes, that makes it great for surface 3D models, but that works very effectively for prismatic parts too, and in a lot of ways can automate things. So I will just say, if you've got access to the paid products, you have access to 3D, use it even if it's a 2D part. Let's see if there's some more questions that are relative here. Renumbering tools, yes. So let's start. Looks like there's a couple questions that aren't relative to adaptive, but we're happy to answer. You've got 2 tools in here, so if you can just open up the tool library, Wayne, and just show how we can renumber the tools. So Wayne's going to go to the tool library.
Yep, there's a few different ways. You can go right up to this tool library here, or you can do it right inside your toolpath. So if I go into the library, it accesses that tool library, and this is the current tool that I'm working with right now. If I wanted to edit or make any changes to that, I just right-click and edit. You can also hit Alt and return. Now, if I want to change the number, I go into the General tab, and I can make this become number 2 or any number that makes sense for me to work with, and say OK, and it updates, and now this is now number 2. And if I wanted to add it to my library, I can right-click. I can copy it. I think I can even do a click and drag in HSM Works. But if I wanted to bring it to another library, let's say I wanted to add it to my Haas Mill Inch library, I can bring it into here, right-click, and I can paste it in there, and it pastes that tool right into that library.
Okay, so now there's 2 more tricks. So go back to your file there, right there. Now right-click. And I think what this user is asking for is renumber tools. So the 4th one down, renumber tools. Click that because I want to show 2 tricks.
Yep.
You can have your first tool number and then the increment. So you can say I want to start at tool 5 because the first tool in your machine is a probe, and the next tool in your machine is always your face mill, or whatever that might be. So renumber and increment by 1. The other trick, Wayne showed adding a tool to a tool library. What I like to do is actually do my increment to be 0 at 0. And what that'll do is actually strip all of the tool numbers off, and I do that a lot when I'm putting my tools in a tool library. That way the tool has no tool number, and then when you select it for the first time, instead of having a tool number, it just logically selects the next one, and that can minimize your need to have to renumber tools. So a couple little tricks. You can renumber tools in your library, starting at 0, increment by 0, and that strips the tool number. It's not going to work in a file because it needs a tool number in a part file, but in a library it can. And then when you use it, now it just grabs the next available tool number for that part file. The next question we had here came up a couple times. Wayne, can you just pop over to the Heights tab? There's some questions around how the Heights tab works.
Okay. So in Heights, we're really easy to work with. It shows you where your clearance height is. Clearance height, this is going to be where your tool is going to go to make sure that you're clear of any fixtures or the stock or the part anywhere that you're going to be clear from hitting anything. Your retract height, this is where the tool is going to go in between sections of your toolpath or moving from one place in the toolpath to another, where the tool is going to retract safely away from your stock or your part. Your top height, this is the place where you're looking at where your feed is going to start. So your top height is where the top of the part, if you're coming and approaching in the Z, that's where you're going to start feeding into the part itself. And then the bottom, of course, is where the bottom of the tool will be. So in this case, if I wanted to select, you can choose these for any one of these. You can select off the model. you can choose where you want it to be. If I want it the bottom of the part, let's say to be from a selection, and I want to select the bottom of the tool, to see, let's say to that edge, I can select that edge, and the bottom of the tool will be only at that edge. It won't go below that edge, but that's where the bottom of the tool will go.
So I better add two little comments here, because I think there's a lot of new users here and I don't want them to get mistaken. So, and everything you said was right, but the first one is the top height. The top height is where the toolpath should start, but you may notice if you're trying to get in real close, like a helical ramp has a helical clearance, so even though your top height might be the very top, you'll notice the toolpath starting higher, because on the linking tab you've got a helical clearance value that says start the helix slightly above the top height. So that's something to think about on the top height. On the bottom height, that's sort of containing the Z limits of your toolpath, it's going to contain the Z level to that height. But if you're doing something like a 3D parallel toolpath, where HSM works, it's high-speed machining. People often thought that was because of adaptive. It's actually because of the nice smooth transitions we do between the toolpath to keep the machine running fast and smoothly. We create smooth linking moves from one toolpath to the other, and that smooth linking move may drop below the top height because those heights are containing the toolpath, not the total motion of the tool. So just keep that in mind. You're not saying the tool will never go below this point. You're saying this is the bottom of the surface that I'm finishing. So back to that point, if there's a vice face or something, add something like a check surface, or add the vice's model geometry so that the toolpath knows it shouldn't gouge into it. So I just wanted to make sure you touch on that when we cover the heights.
Perfect. No, that's great.
It's also important to know that it's associative, so try not to hard code it. The retract height is always from stock top. So our default option is whenever it retracts, it goes 200 thou above the stock top, even if you've set 0 to be 50 feet below the part. But in this case, just at the bottom of the part. I think it's a good thing to remember, because I think a lot of people have an idea that you always have to put your origin at the top of your part so that your retract heights are relative to the origin. You know, an inch up stays an inch above the part. I say that because I like to put my datum at the bottom of the part. Why do I do that? When I flip the part over, it's still the top of the parallel bar, so I don't need to re-pick up Z. And I think a lot of the habits of putting the datum on the top of your part was making sure you had a retract that cleared the part. So bear in mind that default is above the stock, so you shouldn't have to worry about where your 0 is to still have a safe retract. Uh-oh, there's a lot of questions. A couple questions are on the recording. Wayne will clean this up, and everybody will get an email to the recording of this webinar. So that covers a couple of questions. There's a question about the upstands. We think there's some better, so what do I mean by the upstands? You may have noticed sort of a knife edge that's produced on that last pass when you're sort of adapting into the center, and that's that sliver of material the user's asking about. About a year ago, the toolpath would go right along the edge, and sometimes that would just bend the edge over and it would flap around a lot. We made an update to say that last pass will actually machine past the edge and cut a little bit more along the center, and that got things a little better. I think there's still some ways we can improve it. We have some ideas for how we might attack it, but for now, the update that we've made is there's some overlap of the cutter on that last pass, which we've hard-coded in to the software. I say we hard-coded it because it is a value that we could expose to users if we got enough feedback saying that that last pass overlap is something you want control over. Yes, there's a webinar every week. Next week, I'm going to give a plug for one of my buddies, Rob Lockwood, who is, I call him the king of HSM, but he is a master using the software, so he's going to be diving into some 5-axis stuff next week. But yeah, Wayne and the team arrange a webinar with specific topics.
Actually,
how big a step over can you use? Okay, so this adaptive, and again, I highly recommend, not just because I did it, but watch that video at Pier. The thing you want to keep in mind with adaptive clearing is use the full, I always say use the full flute of the cutter, you paid for it. And then you're adjusting your step over instead of the step down to maintain your optimal load, the amount of work you want that cutter doing. The easiest way to look at it is actually every cutter manufacturer supplies peripheral cutting recommendations for what you would have done if you're contouring in a straight line. And even though adaptive is going all over the place, really what we've done is maintain a constant side load. So effectively drive that tool the same way you would drive it if you were just doing a straight cut along the side of the part. And that should give you the best starting point. And then what I've mentioned in the video was once you've done that first pass around the part, the tool will never see more engagement. So you can start adjusting your speeds and feeds and not worrying that halfway through the cut you're going to bury it into a corner. So it does give you a lot of control over fine-tuning your cut recipe on your machine, and then just make sure you save it.
So if you guys want to you can go to our Autodesk HSM Cam website. You can also do a Google search for adaptive clearing at Pier 9. That's the video that Al's talking about. It's fantastic.
Okay, there's a question about the first cut around the outside. We do need to make some improvements in the software in this regards. There's not a way currently to have a different depth of cut around the outside to accommodate for varying thicknesses of stock. So for now, the best way to solve that is to oversize your stock in the definition of the setup. Cody, you're onto something. That second half of your statement is the idea we're exploring. It's easier said than done to do it in an automated way, but yeah, that's what we're looking at, is to actually leave the upstand a lot bigger and attack it slightly differently. Can you avoid areas? Okay, so I actually did a video a little while ago that's containing 3D toolpaths. If you go into this toolpath here, Wayne, and go to the Model tab, you'll see in the Model tab something called a Model Override. This is a little easier to do in the Autodesk products. I'm just going to shamefully say that because we have a lot better direct editing, but SOLIDWORKS has got some of that now too. What you can actually do that some people don't realize is duplicate the body that you're machining. You can simplify it by deleting the features you don't want to get into, and then for just this specific roughing toolpath, you can drive your strategy off of the simplified model that doesn't have those areas that you don't want to get into. So leverage the CAD environment. It's not just because you have an associative tool. Really think about having integrated CAM as having access to more robust CAD functionality for doing things like that. There is an option to just automatically not machine cavities with adaptive, but I think your question is more, I want to get into the big ones, but not the little ones.
What I've often done was I create a configuration in the part that simply has those components or that feature removed, and it makes it easier for me to just machine this nice and smoothly, and then I'm able to turn that configuration on as I need to be able to cut those additional features.
Yeah. Now, if you're in SOLIDWORKS, because you can have multiple configurations on at the same time, Wayne's in an assembly, so you can stack those parts on top of each other and access each of them. So I'd love to talk all day, but there's one of these every week, and usually time at the end of each of them. I think we better turn it over to Jordan to wrap things up. Did an excellent job.
Al, really appreciate it. Thanks for being here. It's awesome.
Yeah, absolutely, Al. That's great. You know, the more time that I can steal from these guys, I think the better the community will be. So Al, you know, forgive me in advance if I become incredibly annoying and harass you every week to try and get you to join Wayne and myself, because it's just great having you here.
You've been equally annoying in getting a large number of users in one place. It's a great, I often say people think as a product manager your job is to come up with all the good ideas, and that's actually not the truth. My job is to have a good set of ears to listen to the customers and communicate that back to our development team, You've done a great job creating a nice community on this webinar. It's a good place for me to get feedback to take to dev.
And that's a nice transition. So if Al's doing a good job, I'd like to ask the community here, what's the likelihood that your company is ready to reduce programming and cycle times and improve profits? Now, we understand that a lot of you joining us today are already customers and are, passing the good word of HSM along to your friends and family. So get your votes in really quickly, and we'll close the poll as soon as I get a good distribution. And wow, Al, Wayne, I think you guys are going to be impressed with the response here. Any thoughts? Do we have people that are no thanks, I want to go, or I'm fine with what I'm doing right now, I'd love my punching bag, or do we have HSM champions? So let's just find out. Share this result. Look at this. 80% of the crowd today is already using HSM technology. 80%. That's phenomenal. So a couple last things for those of you that aren't familiar. Wayne, if you've got the screen, can we pull up a browser? And I want to show everybody the Autodesk education program. For those of us that have friends and family that are in school, that are potentially teaching, education's been a huge part of my life, and I always like to make sure that everybody knows that this program's available. It used to be a very lucrative business for Autodesk, and Carl Bass made the decision to give away the software for free. So all you need to do is Google Autodesk Education. You can come in here and you can get a ton of software. Just a great offering. Even outside of the HSM product line, you can get whatever you'd like, really. But encourage your friends and family and the students that you know, and even the educators, the teachers that you know, to take advantage of this program, because it's truly just a gift. The other resource I'd like to direct everybody to is the Autodesk the Autodesk Knowledge Network. This is a great place to come and find out more information about just really anything related to Autodesk. So you can search by product line and whatnot, but this is a really great resource. So everybody should be bookmarking this resource as well. And so say if you're doing things around additive, for example, additive manufacturing, you can find everything you need to know through here. And then HSM as well. It's all included. So next week, we've got a really special guest, as Wayne was talking about, Rob Lockwood. Please tune in, come back, invite a friend. We're trying to get everybody to invite a +1 to these events. So if they're just interested, it's the same place, same time, new content, and next week you're going to get to hear from an actual HSM power user and customer. And for those of you that want to have access to the old recordings, the old webinars, since we do these every Friday, let us know. We post a lot of these on YouTube. We can also send you links if for some reason you haven't gotten them in the past. So really easy to get in touch with me personally. It's just jordan.roberts@Autodesk. Jordan spelled like Michael Jordan, for example, or the country or the river, and we'll get you tuned up. So thanks again, guys. Wayne, Al, really appreciate your time today. Super beneficial. And have a great weekend, everybody. Please join us next week.
Thanks, guys. Thanks, Jordan. Al, you rock. Thank you very much.
Al does rock.
Just part of an excellent team.